Very often, in the previous videos, we've seen the OH, the alcohol, converted into a good living group in the form of water. But there's another very useful way of converting that alcohol into a good living group, and that is in the form of a tosylate. So alcohol, as I said before, is per se, it's a bad living group. That OH minus is not good. But if it's converted into a better living group, then it can leave. So in this case, alkyl tosylate can be useful. This whole thing is what we call the tosyl group. And if you think about it, when this whole thing leaves, I mentioned it in a previous video, when this whole thing leaves and we have, let's see, when we have here the O minus, there's so much resonance and all these electrons are delocalized, and that is a really great living group. So the tosyl group is just this part, but then when we add the O from the alcohol, it becomes like this, right? So just be aware of the difference. So again, the alcohol will react with the tosylate, and the way this will happen is you have here the mechanism, the lone pair on the oxygen attacks the sulfur, and now the Cl leaves as the living group. Again, we have pyridine, and the pyridine will take away that extra hydrogen, and now this whole thing is the living group. Now, nothing else happens unless you put a strong base, or so this can be used for both substitution or elimination reactions, as you will see, but nothing else happens unless you react it with a nucleophile or with a base. So that's exactly what we are saying here. Now, if you take the tosylate and you react it with a strong nucleophile, we will get an SN2 type reaction, or if we react it with a base, you know that an elimination reaction will happen. So the tosylate part is just to make that alcohol a good living group. But then you can do whatever you want with it. You can react it with a nucleophile to get the SN2, or you can react it with a base to get an elimination reaction. Now, I would like you to be aware of what happens with the configuration of that center that is being attacked. So if you do an SN2 reaction, remember that there is inversion of configuration. But when you put that tosylate in place, nothing changes in that center. So when we have the alcohol right there and you add the tosylate, the configuration is the same one. Nothing happens to the configuration at that alcohol. But when you react it with a good nucleophile, such as this one, and then there's an inversion of configuration, then it's when you go from a wedge into a dash, because there is a backside attack, because we're going through an SN2 type reaction.